Hi everyone, my name is Varsha Chaudhary. Today I'm going to discuss about some topics of computer architecture and organization. So computer architecture is basic architecture of computer where we are discussing about some fact of computer architecture. Computer architecture refers to the overall design of a computer system, including the hardware and software components that make up the system and how they interact with each other. Computer architecture provides the functional details and behavior of a computer system. It involves the design of the instruction set, the microarchitecture, and the memory hierarchy, as well as the design of the hardware and software components that make up the system. Computer architecture mainly deals with the functional behavior of a computer system and covers the what to do part. It means what we can do with the help of computer architecture. It gives the functional description of requirements, design, and implementation of different parts of a computer system. Here, the diagram represents the basic architecture of a computer system. Here, we are using CPU, where control unit, instructions, processor, registers, combination of logic units, main memory, input and output are used. Now, the basic difference between the computer architecture and computer organization is computer architecture explain what a computer should do, what can we do with the help of a computer system, and computer organization explains how a computer works, means how we can work and the what is the process behind a computer or work. If we want to organize some operations like addition, multiplication, divide, then what is the logic behind the multiplication and addition is known by computer organization. Now, computer architecture provides functional behavior of a computer system. Computer organization provides structural relationships between parts of a computer system. Computer architecture deals with high level design. Computer organization deals with low level design. Computer architecture assists in understanding the functionality of the computer. Computer organization helps to understand the abstract arrangement of a computer. Now, computer architecture is designed first, computer organization is started after finalizing. Next, there are some generations of computer in computer organization. So we have five types of computer generation, which is first generation computers, second generation computers, third generation computers, fourth generation computers, and fifth generation computers. The duration of first generation computer is 1940 to 1956. The first generation computer consists of a vacuum tube. The technology used in first generation computer is vacuum tube, and it is used main memory, and it is very large in size and low speed computers. The second generation computers duration is 1956 to 1963, and these computers are mainly based on the transistor. Third generation computer systems duration is 1964 to 1971, and the third generation computer consists of integrated circuits, that means ICs. These are high level programming languages computers, and it is used magnetic tape, monitor, keyboard, printer, etc. The time is fourth generation computer. Fourth generation computer duration is 1972 to 2010, and the fourth generation computer consists of a VLSI chip, that is a microprocessor, very large scale integration and microprocessor. The memory is used such as RAM, ROM, etc. And last generation computers are fifth generation computers, and the duration of fifth generation computers are 2010 to till now, and the technology is used in fifth generation computer is AI, artificial intelligence, and it is portable and small in size, and we can easily use these computers. Our desktop, laptops, tablets, smartphones, etc. are the examples of fifth generation computers. Now, there is one important fact in computer architecture, where von Neumann defined their model. Von Neumann is a scientist who defined their model regarding computer. Von Neumann proposed his computer architecture design in 1945, which was later known as von Neumann architecture. It consisted of a control unit, arithmetic and logical memory unit, that is ALU, register and input outputs. Von Neumann architecture is based on the stored program computer concept, where instruction data and program data are stored in the same memory. The design is still used in the most computers proposed today. So the diagram shows the von Neumann model. In von Neumann model, we use ALU and CU as in diagram shows ALU and CU. There are some registers also like PC, that is program counter, CIR, current instruction register, AC, that is accumulator, MAR, memory address register, MDR, memory data register, memory unit, input device and output device. Now, von Neumann model consists of main three components. First main component of von Neumann model is central processing unit, that is CPU. Second main component of a von Neumann model is buses, and third main component of von Neumann model is memory unit. The CPU is our central processing unit, which covers the arithmetic and logic unit and control unit and verified set of registers. Buses are the means by which the information is shared between the registers in a multiple register configuration system. There are three types of buses: address bus, data bus and control bus. Memory unit consists of a collection of storage. The internal structure of a memory unit is specified by the number of words it contains and the number of bits in each word. Two major type of memories are used in computer system, that is RAM and ROM, random access memory and read-only memory. Here, the various CPU registers are shown in the figure, and the process of fetch a instruction and decode the instruction. That means if we want to search about some instruction, if user system want to save some storage, or if they want to fetch, decode or execute any instruction, the fetch operation is utilized for taking the directions by the client. The instructions that are stored away into the main memory for later processing are fetched by registers. Decode, the operation is utilized for the disappearing the instructions, implies the instructions are decoded. The CPU will discover which operation is to be performed on the instructions. Execute, the CPU performance these operations also result delivered by the CPU and then stored in the main memory, and after that they are shown in the client screen. Now we are having many types of registers in computer organization. Some types of registers are showing as you're on screen, the name of register and the symbol which we can indicate the register and what is the functioning of that register. So first register is our accumulator, that we can represent by AC. AC is represent accumulator, and the functionality of an accumulator is the most often utilized register, and it is used to store information taken from memory. Second type of register is memory address register, which is symbolized by MAR. The memory address register address location of memory is stored in register to be accessed later. It is called by both MAR and MDR together. Third one is memory data register, which is symbolized by MDR. The functioning of MDR is all the information that's supported to be written or the information that is supported to be read from a certain memory address is stored here. Now fourth one is general purpose register, which is indicated by symbol GPR, and the functioning of GPR is consist of a series of registers generally starting from R0 and running till Rn-1. These registers tend to store any form of temporary data that is sent to a register during any taking process. More GPR enables the register to the register addressing, which increases processing speed. The next register is temporary register, which is denoted by TR. It holds temporary data. Up next is input registers, which is INPR, carries input character. The seventh register is program counter, which is indicated by PC, and the functioning of PC is these registers are utilized in keeping the record of a program that is being executed or under execution. These registers consist of the memory address of the next instruction to be fetched. PC points to the address of the next instruction to be fetched from the main memory when the previous instruction has been completed successfully. Program counter also functions to count the number of instructions. The increment of PC depends on the type of architecture being used. If we use a 32-bit architecture, the PC gets incremented by 4 every time in each fetch next instruction. The next register name is output register, and we indicate this OUTR. It carries output character. Ninth register is instruction register, which is indicating by IR, and the work of IR is instruction register hold the information about to be executed. The immediate instruction received from the system are fetched and stored in the registers. Next is condition code register. These have different flags that duplicates the status of operations. Next register is indexed register, which is explained by BX. We use this register to store values and numbers included in the address information and transform them into effective address. Next one is memory buffer register, which is indicated by MBR. MBR buffer register also used to store data content or memory commands used to write on the disk. The basic functionality of this is to save call the data from memory. MBR is very similar to MBR. The next register is segment register, SR, hold address from memory. Up next is stroke control register, SCR. Stack is the set of location memory where the data is stored and retrieved in a certain order. The next register is data register, DX, holds the memory operand. The next one is flag register, that is FR. Flag register are used to indicate a particular condition. The size of register flag is 1 to 2 byte, and each register flag furthermore compounded in 8 bits. Each register flag defines the condition of a flag. Basic flag register are zero flag, carry flag, priority flag, sign flag, and overflow flag. Thank you.